Today we are working on section 1.2. This first problem deals with the volume of a cylinder, and we know how to find the volume of a rectangular prism. I'm not very good at this. There we go. So if this was 2, and this was 3, and this was 6, we find the area of the front, and let's say this is in inches. So 3 inches times 2 inches is 6 inches squared. That's how many squares there are. Oh, I drew that wrong, but whatever. You get the idea. That's how many squares 1 inch by 1 inch are on that front face. To find the volume, we have to stretch it by 6 inches. So we times that by 6, and we get 36 inches cubed, which means there are 36 cubes that are 1 inch by 1 inch by 1 inch. Okay, and that idea actually stretches to cylinders or any other shape that has, well, it's called a cylinder, but you guys don't really know what a cylinder is. This is an example of a cylinder, but there are other things that are also cylinders that don't have that same shape. But anyway, so we know that the radius of the pipe is 1.5 feet, and it's 15 feet long. So we need to find the area of this, and then we'll just multiply it by the length. So area is pi r squared, 3.14 times 1.5 feet squared. 3.14 times 1.5 squared is 7.065 square feet. Now we're going to stretch that area by a factor of 15, and I get 105.975, and it wants me to round to the nearest whole number. So 106 what? Feet cubed. So it would be this one. Okay? All right. We need to find the area of the shaded region. So we have a rectangle, and we have a triangle. The area of a rectangle is length times width. The area of triangles would be length times width divided by 2, and we usually say 1/2 base times height, but it's the same thing. Why does that work? Yeah. So if I were to extend this out, now I have a blue rectangle, and the area of that rectangle is going to be 6 times 8. And the triangle is exactly half as big as the rectangle. Now the weird thing is, if you had a rectangle like this with a triangle that looked like that, so this is base and this is height, is that triangle still half of the rectangle? Yes, and you can see it if I do this. That is half of the left rectangle, and this is half of the right rectangle. Okay, so the area of our rectangle is going to be 60 centimeters squared. The area of our triangle is going to be 1/2 times 6 times 8 is 48. So that would be 24 centimeters squared. And the shaded region would be what? So this is all of that, and this is that. So to find the shaded region, I just take 60 and subtract 24, and I get 36 centimeters squared. Any questions? Okay. Okay. The solid below is made up of cubes. Find its volume. So we have a 6 and a 2 and a 4. So 6 times 2 is 12 times 4 is 48 cubic yards. A company makes concrete bricks shaped like rectangular prisms, which is just a brick. Each brick is 11 inches long, 8 inches wide, 5 inches tall. If they used that much mud to make the bricks, or that much concrete, how many bricks did they make? So each individual brick is 5 by 8 by 11. So 5 times 8 times 11 is 440 cubic inches of concrete per brick. So how do we figure out how many bricks they used, or how many they made? Each brick takes up that much volume, and they used that much concrete. So we'll just take 11,000 and divide it by 440, and I get 25. What if I would have got 22.9? What would the answer be? How many bricks did they make? We need to round this. Would we round it up to 23 or down to 22? Down. Why? Yeah, we're counting full bricks. So they had a little bit left over. They tried to make one more brick, but there wasn't enough to fill the mold. So in this case, even though it's a 0.9, we would round down because we're only counting full bricks. All right. So here we have a sphere, a cube, and a square pyramid. I don't know if there are other options, but those are pretty self-explanatory, right? There might be other examples too that you're going to run into. And another volume problem. Okay. Work on 1.2. Get to work.